Okay, so on to part 3 of this video. So we're going to do a couple more examples here. Directions for the first say to find f if f prime of x is equal to e to the x power plus 20 times the quantity 1 plus x squared raised to the negative 1 power. And f of 0 is equal to negative 2. So this part of the problem is brand new, and it actually changes this problem into what is called an IVP, which is an initial value problem. Okay, so when you're looking at initial value problems, they're going to be different than like general antiderivative problems in that the initial value that we are given is going to allow us to find a particular value for C that satisfies the given information. So we're not going to just add some general C to the end, but we're going to find a specific or particular value for C that satisfies the information in this problem. Okay, so what I'm going to do to start with is I'm going to rewrite f prime. The first term I'm going to leave alone as e to the x power. But I'm going to rewrite the second term as 20 over 1 plus x squared, because I think writing it in that format makes it easier to see, number one, that you can take an antiderivative of that, and number two, like what the antiderivative of that function is going to become. Okay, so to take the antiderivative here, the antiderivative of f prime is going to be f. We can take the antiderivative of e to the x power, that's e to the x power. I can take 20 and pull it out front, and then take the antiderivative of 1 over 1 plus x squared, which is going to become the inverse tangent of x. And then we're going to add the constant c to the end. Okay, so what we want to do now is we want to take the initial condition that we're given, or the initial value. We're going to plug that value in for x and y respectively, and then we're going to use that to solve for the constant c. Okay, so we know f of 0 is going to be equal to negative 2. So we're going to plug 0 in the place of x, which is e to the 0 power plus 20 times the inverse tangent of 0 plus c. So we get negative 2 equal to e to the 0 power, which is 1. And we have 20 times the inverse tangent of 0. So if we want to find the inverse tangent of 0, we want to think to ourselves, the tangent of what angle is equal to 0? And we know our angle measures for tangent have to be between negative pi over 2 and pi over 2. So the tangent of what angle between negative pi over 2 and pi over 2 is 0? Well, that's going to be equal to 0. Okay, so then we have our equation becoming negative 2 equal to 1 plus c, which makes c equal to negative 3. And if c is equal to negative 3, then our function f of x becomes e to the x power plus 20 times the inverse tangent of x minus 3, okay? And when we have an initial value like that, again, we're going to be able to figure out the value of the constant c in your antiderivative. Okay, let's move on to the next one. So next one, directions say to find f if f double prime of x is equal to 12x squared plus 6x minus 4. And then we're given f of 0 is equal to 4, and f of 1 is equal to 1. Okay, so different than the last one in that we are given f double prime and we want to find f. We're also given two initial conditions in this problem. Okay, so when we look at f double prime is written in a form where I can take the antiderivative term by term here. So let's go ahead and do that. So I can pull 12 out front. Antiderivative of x squared is x cubed over 3. Plus, I can take 6 out front. Antiderivative of x is x squared over 2. Minus the antiderivative of 4 is 4x. And then to that, we're going to add the constant c. Okay, so I just want to go through and simplify this. So 12 divided by 3 is 4x cubed. 6 divided by 2 is 3x squared minus 4x plus c. Now, when I look at my initial conditions here, I don't have an initial condition that pertains to f prime. If I did, I'd want to plug that initial condition in right there to figure out the value of the constant c. Okay, but I don't have one that pertains to f prime, so there's nothing more that I can do with f prime. I now have to take the antiderivative of that function. So the antiderivative of f prime is going to be f, and then we're going to take the antiderivative term by term. Again, if you can take the antiderivative of 4x cubed and 3x squared and negative 4x, just immediately do it. I'm just going to work it out like step by step so everybody can follow along in case you're having difficulty with this. Okay, so I would pull 4 out front. Antiderivative of x cubed is x to the 4th power over 4. Plus, I pull 3 out front. Antiderivative of x squared is x cubed over 3. Minus, I pull 4 out front. Antiderivative of x is x squared over 2. Plus, the antiderivative of c is cx. Plus, we add a new constant d to the end. Okay, and then I just want to go through and simplify term by term. So first term simplifies to x to the 4th, plus next one is x cubed, minus the next one to x squared, plus cx, plus d. And then I want to utilize my initial conditions to find c and d. Okay, so for me, I think the best way to do this is to use this initial condition here first, because I know f of 0 is 4. So when I plug 0 in the place of x, the only term I'm going to have left on the right-hand side is d, which is going to make the function f of x equal to x to the 4th plus x cubed minus 2x squared plus cx plus 4. And then I can use the second initial condition where f of 1 is equal to 1. I can use that to solve for c. So when I plug 1 in the place of x, we get 1 plus 1 minus 2 plus c plus 4, which makes 1 equal to the 1 plus 1 and minus 2 cancel. So that leaves us with c plus 4, which makes c equal to negative 3, which thereby makes the function f of x equal to x to the 4th plus x cubed minus 2x squared minus 3x plus 4. Okay, I'm going to have you guys give the next example a try. So this time we're going to take antiderivatives and relate that concept in with particles in motion. Okay, so we're given that a particle is moving with the given data, and then we're asked to find the position of the particle given the acceleration at time t is equal to the cosine of t plus the sine of t. We're told s of 0, which is the initial position, is 0, and v of 0, which is the initial velocity, that's going to be 5. Okay, so I want you guys to find the position s of t. Go ahead and pause the video whenever you're done. Go ahead and unpause it, and then we'll take a look at the solution together. Okay, so we're given acceleration. We know that the antiderivative of acceleration is velocity, and I can go ahead and take the antiderivative of the acceleration function the way that it's written right now. So the antiderivative of cosine is sine, again, because the derivative of sine is cosine. And then the antiderivative of sine is negative cosine. And then we're going to add the constant c to the end. And when we look, we do have an initial condition that pertains to velocity, so we're going to go ahead and plug that in and use that to solve for the constant c. So we know v of 0 is equal to 5. Oops. And then when we plug 0 in the place of t, the sine of 0 is 0 minus the cosine of 0 is 1 plus c, which makes c equal to 6. Thereby making the velocity function v of t equal to the sine of t minus the cosine of t plus 6. Okay, then to get to the position function, we have to take the antiderivative one more time. So the antiderivative of velocity is position, and then we're just going to take the antiderivative term by term. So the antiderivative of sine is negative cosine minus the antiderivative of cosine is sine. The antiderivative of 6 is 6t. And then we're going to add a new constant d. And then we're going to take the initial condition that pertains to position and plug that in and use it to solve for d. Okay, so we know s of 0 is 0. And then when I plug 0 in the place of t, we get negative the cosine of 0, which is negative 1, minus the sine of 0, which is 0, plus 6 times 0, which is 0, plus d, which makes d equal to 1. And then once we have that, we're just going to plug that value into our position function, which makes position equal to negative cosine of t minus the sine of t plus 6t plus 1. Okay, last example for this lesson says that the graph of f prime is shown in the figure, and then you're asked to sketch the graph of f if f is continuous and f of 0 is equal to 3. Okay, so this is going to be your graph of f prime. And I want you to use it to sketch the graph of f. Again, pause the video here. Go ahead and work this out on your own, and then you can turn the video back on to check to see how you did. Okay, so let's check and see how we did with this. Okay, so we're going to look at this concept of antiderivative graphically now. Okay, so there's a couple of pieces of information that are important in the problem. Number one is that f of 0 is equal to 3. So that right there is going to give me my starting point for the graph of f. The graph of f is going to start at the ordered pair 0, 3. Okay. Secondly, the fact that f is continuous means that I better be able to sketch that graph without lifting my writing utensil. And then when we look at the graphs on the left, If we're given the graph of f prime, what does f prime tell us in regards to the function f? Well, f prime tells us the slope of the graph of f. So between the x values of 0 and 1, we know the slope of the graph of our function is -1. Okay, so I should be able to go from this point at 0, 3, having a slope of -1 to take me to the next point here. So I go down 1 and to the right 1. That takes me to my next point. Now, when you look at f prime is undefined at x is equal to 1, which tells us that we're likely going to have a corner at that point. Okay, so when we look at f prime's values between 1 and 2, f prime's values between 1 and 2 are 2. So that means the slope of my graph in between the x values of 1 and 2 are going to be 2, which means I'm going to go up 2 units and to the right 1 unit, which puts my next point there. And I'm going to draw a segment connecting those 2 points. So when we look at x is equal to 1, the graph has a corner there. That's why the derivative is not defined at that value. Okay, and then lastly, when I look at the x values between 2 and 3, f prime's value is 1 there, which means the slope of my graph between x is equal to 2 and x is equal to 3 is going to be 1. So I'm going to go up 1 and to the right 1 from that point, which is going to put me here. Draw a segment connecting those 2 points. Again, we have a corner at x is equal to 2. That's why our derivative is undefined at that value. Okay, so that's an example of like taking a look at antiderivatives graphically. And I want you guys to be able to like take what we're doing and apply it in different types of contexts like that. Okay, all right, so that's it for your 3 lessons on section 4.9. We'll see you guys in class on Monday. Take care.